As Resnick mentions in section 5.1 of your text, there are two different ways of formulating games from a mathematical perspective. They match exactly the way we formulated decisions earlier in this course when we were doing rational decision theory, where individuals were playing against the environment, chances of events happening in the environment. One is as a tree, and the other is as a table. Now, for a variety of reasons, Resnick in this chapter focuses on the representation of games in table form. And when you lay out a game in table form, particularly in this case, a two-person game, in this place, one person is row, one person is column. Row has a choice between strategy R1 and strategy R2. Column has a choice between strategy C1, C2, and C3. So basically, the rows indicate the choices that one of the players has, and the columns indicate the choices that the other player has. And here's how to read a table. The table lists the outcomes of utility rankings on rows and columns' personal utility ranking. If row were to play R1 and column were to play C1, both of them would receive 0 in terms of the outcome on their utility scale. Now, this particular first list in the outcome is the outcome for row. The second list in the outcome is the outcome for column. So if row plays strategy R1 and column plays strategy C1, they'll end up on this point on the table or the matrix, and both will wind up with 0, an outcome that they rank 0 on their utility scale. On the other hand, if row were to play R1 and column were to play C2, row would wind up with an outcome of 1 on his utility scale or her utility scale, and column would wind up with an outcome of 2 on his or her utility scale. And similarly for R2 and C3. If row plays R2, strategy R2, column plays strategy C3, the outcome will be an outcome of 0 for row on row's utility scale, and an outcome of 0 for column on column's utility scale. Now let's look at this from the perspective of game theory. First, let's look at it from row's perspective. Row is going to look at and compare the outcomes of playing R1 or playing R2. Row knows that if column plays C1, row will do strictly better by playing R2 than by playing R1. If column plays C2, row will do just as well playing R2 as playing R1. And if column plays C3, row will do just as well playing R1 rather than playing R2. Realizing this, row notices that R2 weakly dominates R1 for row. It has a better outcome in one of column's choices, and it has an equal outcome in the other. So row, being a rational agent, will never play R1 and will always play R2 because it weakly dominates R1 for row. Knowing that, and knowing that row is a rational agent who's going to work to maximize his or her expected utility, column, knowing row is going to play R2, is going to play C2 to maximize column's outcome, because if column were to play C1, column would only get 3. If column was to play C3, column would get 0. So once column realizes that row is going to play R2, column will play C2 in order to maximize his or her expected utility. And notice that the exact same reason works if you think of it from column's perspective. If column is reasoning which of these particular ones to play, column will notice that if row plays R1, column will do better by playing C2 or C3 than column will do by playing C1. But if row plays R2, column will do better playing C2 rather than C1 or C3. So column notices that that column that column 2 weakly dominates. It strongly dominates column 1. It pays off better in both of Row's choices, and it weakly dominates C3 because it pays off the same in this one and pays off better in this one. So C2 strongly dominates C1 for column. C2 weakly dominates C3 for column. So column is going to decide to play C2. From Row's perspective, Row knows what column's utilities are. Row knows that column is a rational agent. And so knowing that column is going to play C2, right, Row, of course, if Row knew that, Row could play either one. But again, Row is going to play the outcome in this particular case, as we reasoned before, since R1 dominates R2, Row is going to play R2, and they're going to wind up at that particular point in the matrix being two rational agents, both playing their preferred dominating strategy. And so we have solved this game. We know exactly where rational agents will wind up in this game. They will wind up at a solution of R2, C2, and the payoff will be Row's payoff will equal 1 on his or her utility scale, and column's payoff will equal 4. The game has been solved. It has a single solution, and in this particular case, the solution is the play pair R2C2 with a payoff of the game of R equal to 1 and column equal to 4.